Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones.
Hi, it's equipment review time again. And yes, it's another multimeter, but it's the one everyone's been asking for. I keep getting emails all the time. Dave, can you review the top of the line Agilent U1253A multimeter, the one with the OLED display? All right, no worries. I've got one. Here it is. Thanks to Alistair at Farnell's in the UK. Now, I was going to hold off reviewing this because when Agilent heard I had one, I was going to review it. They said, hey, do you want to review the brand spanking new one, which has just come out, which is the B model. It's exactly the same as this, the 1253B. And I said, yeah, no worries. So that's in the post, but I just couldn't wait. So apparently there's not much difference apart from the color and some firmware changes. So I figure it's still relevant to review the old A model. Now, first up, Agilent are the old HP. Agilent are the #1 test equipment manufacturer in the world. So it's good to get a high-end meter like this. They're back in the business, and let's see what they've come up with. Because pretty much Fluke have had the market forever, and they're #1 in the handheld multimeter market. But it's great to have some competition, and let's see if the Agilent stacks up. And of course, it's pretty obvious that I'm going to review it against the Fluke 87.5, which is the industry standard. Being a top-of-the-line meter, the price is top of the line too. This is about $450 US is the recommended price, which is a bit more than the Fluke 87, but you get a lot more too. And you know what we say here at the EEVblog? Don't turn it on, take it apart. There's 3 screws here, and they're actually metal threaded screws into metal inserts, which is fantastic. That's what you expect for a quality meter. Fluke don't give you that, but you pop it off, and very disappointing. I'll tell you what, because it's like opening a product and being mooned or something like that. Because it's just showing its arse end. There's the back end of the PCB, and well, I expected to open it up and see some nice quality components and things like that, but all I got is a arse end of a green PCB. It's a bit disappointing, but it's not bad quality. Anyway, let's check it out. Down here, the input sockets, as you can see, they're just soldered straight onto here like that. So they're not separate things. They're hooked straight onto the board like that. And that's not the best solution, but the soldering is excellent, so there's no problems there at all. I much prefer the input sockets that are just separately mounted and then wired over to the board. I just find that's a more rugged way to do it. Now, the other interesting thing is that there's no high voltage isolation slots. Here, there's a huge distance here, but there's no high voltage slots, and I find that rather remarkable, actually. But to get the board out, you undo 2 screws up here, and it should just lift out. There it is. Whoop, ta-da! It's lifted out, and here we go. Let's now take a look inside this thing. You can see the HRC, 2 huge HRC fuses here, which is fantastic. You can see the input protection, probably fusible resistors there, some overload protection devices, but not a huge range of input overload protection. I'm a tad disappointed, I guess, but each meter's designed differently. Okay, so I've taken the OLED display board off here, and it's got some driver circuitry on the back here, which actually looks quite nice. And it's got a little standard header to plug in to here, and it's got these little standoffs, which are nice. Once again, threaded metal inserts, it's really nicely designed. I like it. And obviously, here's the main processor. What it is, if I get in here and read it, it's an NEC processor. I'll put some high-res photos up later so you can see it, but it's an NEC micro controller. Which is reasonably surprising, I guess. I expected something a bit more mainstream than that. Now, the 9-volt battery, the wires actually go through some strain relief here, which isn't too bad. There's a poly switch down in there for some protection, charging circuitry obviously for the whiz-bang fancy charging stuff they've got. So the internal construction of this thing, it's not too bad at all. In fact, it's quite nice in many respects, but as I said, I'm not blown away by it. I'm not going to write home to my mother about it. It's just, I don't know, it's more of the construction sort of I expected in sort of a mid-range meter than a sort of a high-end one, I think. And really having the fuses on the top, on the top of the board, so that you have to actually take the whole board, the whole guts of it apart to change the fuse, that's really inexcusable. They just should have put more thought into it. And really, I'm not impressed one bit with what looks like, here's a high-res photo of it, of a dry joint on one of these turrets, which I think they've put like a big resistor or a diode in there, some sort of protection device in one of these PCB turrets which go through the board, and the solder just hasn't taken to it. So, that's a bit of a worry. Big differentiator with this Agilent meter, apart from everything else on the market, is its display. An OLED, organic LED display, and check it out. Here it is. Ta-da! Check it out. Now, it's flickering on my monitor here, so I'm not sure if that's going to come through in the final video. It very well may. So I apologize. That's not the meter. That's my actual camera and the frame rate of my camera doing that. So I'll see if I can fix it up later. But check it out. Fantastic. It's awesome. This is the brightest display I've ever seen. It's porn for engineers. Really. Fantastic. It's worth every cent. And if you compare it in the lab, it's just so bright and spectacular. Really, it just draws people into it. Even my wife likes it. She went, wow, look at the display. Ha, fantastic. Thumbs up for the OLED display. Super duper accurate, and the box, I think, is pretty spot on. What does it say? Imagine razor sharp readings. And really, that's what this sucker, it's not a bad slogan, this is what it gives you. It gives you razor sharp readings. It's super accurate on almost every range. You get 50,000 counts, and you get it as a dual display capability as well. For almost all the measurements, you can do selectable dual display. It's great. And the other big selling point is that you've got data logging capability as well. It's got an infrared port on the back for hooking. It doesn't come with the USB cable. You've got to pay that extra, but I don't think it's too much. But it should be in the box, which I think is a bit tight ass of Agilent. But yeah, it's got data logging capabilities. You can take 1,000 measurements with this thing. It's really easy to use, and I'll show you that later. And it's feature packed. It's got much more bang per buck than the Fluke, if you just look at feature and accuracy wise. Size-wise, you can see that they're roughly equivalent meters. They weigh about the same, and it doesn't quite have as solid a feel as the Fluke does, but yeah, it's still very well built. Now, Agilent haven't quite figured out, I don't think, what the rubber holster thing, which you get on Flukes and most other meters, is all about. Yeah, they've added all these rubber bits down the side and around the back and things like that, but it doesn't really give you a sense that it's going to protect the meter as well. Maybe, if you drop it on its edge like that, maybe, but look, if you put it like that, you can see that the range switch is exposed. And really, I think if you drop it and it lands on this battery door, which does move a little bit, I think that's just going to break straight off. So you don't get a sense that you could drop this on the floor and it could survive. It may. I'm not going to try it, but yeah, you just don't get as rugged a feel as the Fluke. You feel as though you have to treat it with a bit more gently than a standard Fluke 87, which is pretty much bulletproof. And here's another thing. Listen to this. It rattles. Can you believe it? A $450 Agilent meter should not rattle. I don't like it. What's the tilt-in bail like? Well, it's a plastic thing. It's a sort of a flimsy sort of plastic thing, but it does break like that, so that you can actually have two different angles of when it sits on the bench, which I think's really good. And the other feature, which you might think is bad, but oops, I just broke it. No, I didn't. It's designed to actually come off. It just clips into little nooks in there and it goes straight back on. So really, I kind of like that. One of the really cool things about this meter is the update rate, the screen update rate. Now, a good meter will have 4 or maybe even 5 times per second updating. Well, the Agilent has 7 times per second at 50,000 counts. It's phenomenal. How it does it, I don't know. And that's in volts and most other ranges, but on the ohms range like this, check it out, 14 times per second. Updating at 50,000 counts. Oh, yeah, the OLED display is fantastic. It's the greatest thing since sliced bread. But the price you pay for it is the battery life. Now, a good meter might have, say, many 800 hours battery life, right? A crap quality one will have 80 hours battery life. What's the battery life of this Agilent? 8 hours. You gotta be kidding me. That's useless. Well, it's not useless, but gee, I can't help get the feeling that every time I pick it up and I switch it on, I get this horrible feeling, is it going to work or not? Is the battery going to be fully charged? Is it going to have enough juice to power this damn power-hungry display? Some people might be okay with that, but I'm not. It'd bug me if I had to charge this all the time. And what they've done is they've used a 9-volt rechargeable battery. It's a terrible choice. It's the worst possible choice you could make, and I think they've completely goofed it up, the design of this thing. A rechargeable 9-volt battery, which they supply in this thing at 300 milliamp hours at 7.2 volts, that's only about 2 watt hours. Now, a couple of AA's would have had more than that, and also the 9-volt battery is a poor choice because there are all the cells inside, 6 of them inside, are in series. And you can get when you try and recharge them, you get the classic reverse cell situation and they die very quickly. Okay, sure, you could argue that, well, if you're going to have this thing out in the field, you should just carry around a spare 9-volt battery in your toolbox, right? Well, that's also a poor choice because the terminals are on top and they can be shorted out. If you're going to carry a spare one, put some tape over it, half-turn, lock-unlock things, which is pretty good for the battery door, and you just slide it off like that, and there's the 9-volt battery. And as you can see, they've put in the little rubber thing on here to try and keep it in place, but as I said, it rattles, and it's just not that great. And I really love the battery charging methodology they've got. Instead of having a DC jack on it somewhere, no, they supply you with some banana plugs, and it charges. Here it is. It's written on the front. It tells you that ground and the milliamp jack. You plug it in there to charge it, and I think that's really clever. Okay, let's see what happens when we plug in the charging here. Here it comes. Ta-da! And it turns on. It beeps at you. Why does it continually beep? It's got a countdown time like it's going to explode in 10 seconds. Quick, open it up, disarm it. But no, there we go. And then it goes into a self-testing routine, and it takes like 3 minutes for this self-test routine. Obviously, it's like testing if the battery is like is it an alkaline primary or is it a rechargeable? And bingo, now it's going to start charging. And what's it saying? There we go. It's counting. It's going to take 1 hour and 8 minutes and 54 seconds to finish charging. Great. I like it. It's terrific. They put so much thought into this. Well done. Being a dot matrix display, it's got a menu system, doesn't it? And here it is. The shift thing, you hold down that and bingo, up pops the menu. And you've got the up-down buttons here, which let you, yep, there we go, which let you cycle through the various menu displays. And then you press the log save button if you want to go in and edit something. And it really is quite nice. And there's like 5 screens of setup information there. And here you go, you've got things like range hold and the DBM settings, and this one's got the K-type thermocouples and the milliamp scale, you can change the frequency of the buzzer and all sorts of stuff. And there's various displays there, and it's really quite easy to use, I think. And I hate menus on multimeters, but this is one of the better ones. I like it. As I mentioned before, it's got a dual display, and you hit the dual button here and you can pop up with all sorts of things. Like you can pop up with the frequency, and then you can pop up with dBMs. Look at that, dBMs relative in this case to 50 ohms, which as I said you can change in the menu. There's also a display brightness button. You can change the brightness level. By default it goes to maximum, so you can actually lower it. I assume that lowers the battery consumption. We'll test that later, but yeah, I don't know why you wouldn't leave it on full, really though, because it's such a sexy display. And yes, having such poor battery life, you've got the auto power off APO, auto power off, displayed on the screen. So that's really handy, so you know it's going to automatically switch itself off, which it doesn't in some modes, like say data logging or something like that. Now let's check out the data logging capabilities of this thing. Now I don't actually have the USB software to try it out, but it's really easy to use. You've got the log button over here, and you just press that, hold it down, and bingo, it says it's login and it counts up. There you go, it's got 19, 20, there you go, it's counting up. It's taking 1 reading per second in this case, but you can change it anywhere from 1 reading per second to 9,999 seconds, I think. But you don't need the PC software to actually review the readings. There's a view button over here, so you hold that in and you go into view mode, and it tells you which data sample you've got, and you can just cycle through the different readings like that. Now, as I said, this has ridiculously fast display updating. Look at it, 14 times per second in ohms. Woohoo! But watch this. What happens when I short the probes out? Clunk, clunk, clunk. It's the world's slowest auto ranging. Oh, it's horrible. On the ohms range in particular, it's awful. But so, I don't know how they can get the display updating so fast, yet the auto ranging so slow. As you can see too, it's got a built-in temperature display, in this case 33 degrees C. Yeah, it's hot here today in summertime in Sydney, but built-in temperature sensor. But something you've got to watch out for is when you charge the thing, the internal battery, it heats up, and you can see it on the temperature display after you've charged it. So a bit of a design issue there. Another really unique feature of this meter, you put it on DC millivolts range, but check what it goes down to. If I short the probes out, ta-da, it goes down to a 50 millivolt range. At 50,000 counts, that's got a resolution of 1 microvolt. Wow! Another really neat feature is that you can go into the menu and you can select a tone display for the ohms range. It'll actually give you a different tone, a frequency tone, based on the value of the resistance. And that's really neat for tracking down faults and things, shorts and stuff like that. It'll change the tone as you're getting closer towards the short. It's like playing a tune as I change the readings. Isn't that cool? It's funky. It's, it's not just a gimmick. And likewise, for the continuity range, you can also change the frequency of the tone if you don't like it, or you can switch it off. Now, let's test the continuity mode, see how quick it is. Oh dear, that is tragic, really pathetic. That is one of the slowest continuity testers I've ever seen. Now, curiously, I noticed if you put it on the diode range, it beeps as well. The continuity is actually quicker. Look, it's probably twice as quick as the ohms range. Why? Ha! And yes, the burden voltage isn't too bad either. 2 millivolts per milliamp burden voltage, so that's pretty typical. It's on par with the Fluke and other decent high-end meters, so that's good. Also, any good top-of-the-line meter will also have a very high input impedance on the low millivolt ranges. In this case, anything less than 1 volt is greater than 1 gigohm. What I expected with this full dot matrix display, you can do whatever you want on there. I expected this to have some sort of very simplistic graph function to show you your log data on the screen, just like the Fluke R289 series, but it doesn't have it. Yes, they've added in some wank features as well, which thankfully you can turn off in the menu. Check this out when you switch it on. Space Invaders, anyone? Galaga? Now, one of the annoying things is it's got a menu option to turn off the beep, but I found that's only for the actual ohms continuity, which I don't know why you'd want to turn it off. You just don't switch it to continuity mode. It's crazy, but it doesn't switch off the button beeps. It always beeps when you push the button. You just can't switch it off. Set a voltage anywhere from 1 volt up to 1,000 volts for over voltage indication. It'll beep at you if it goes over the voltage. Now I've set it in the menu, I've set it to 25 volts. And I'll just turn up my bench supply here and we'll go to 25. Once again, Gallagher anyone? Thankfully you can turn that stupid Gallagher melody thing off. Here we go again. Let's check to see if it overshoots or undershoots a reading when you switch it on. Here we go, watch. Nah, straight to it. Straight to the reading within 1 least significant digit every time when I switch it off and on. So that's excellent. Now another thing I don't like, and I'm probably being nitpicky here, is the font for a 4. Look at it. It's very stylized. There's another cool little feature too in the menu. You can set the input smoothing, whether you want fast, slow, or normal. Nice. There's a whole ton of functionality in this menu system that you don't really see just from looking at the meter. Let's take a look at the probes. As you can see, on the left there is the Agilent one here, and on the right here is the Fluke, and they're just as sharp as the Fluke, if not sharper really. Actually, they are sharper. And I really like the probes supplied with the Agilent ones. They're Agilent branded, they're Cat 3, 1000 volts, and they've got a nice rubber grip on them, and they're just nicely contoured. And yeah, you can get a real sense of very thick silicon insulation on them too. You get a real sense of, safety with these things and confidence. I love it. Now, the other really neat feature of the Agilent is the signal generator output mode they've got here. And you plug it into the milliamp jack, and it outputs a 3 volt square wave at a selectable frequency down here, anywhere from 0.5 hertz. You can adjust the duty cycle, and here it is. I've got this one's 150 hertz, and there it is on the scope, as you can see. And I can adjust the frequency, and boom, and that's a 3 volt square wave, and it's not bad at all. And if you go in there and look at the rise time, yeah, 500 nanosecond rise time, which isn't too bad. You get some crocodile alligator clips as well, but there's no temp probe. I mean, it's got a temp feature on it, but no thermocouple. Once again, it's a bit tight ass. And of course they have a range hold mode just like the Fluke, although they don't call it touch Fluke because that's Fluke proprietary. They just call it range hold. So you press it on and you've got R hold up here, and if you switch, if you temporarily do something, it captures the reading and stores it there. And they've got record, if you hold it down, they've got record, min max and min max average and all that sort of stuff, all the usual stuff. And it survived 240 volts on the ohms range. I've got it plugged into the mains over here, 240 volts. Let's check it out. Let's switch it on to DC. It's surviving. Millivolts, no smoke yet. Ohms range, no, it's surviving. Well, let's go to diode range. Woohoo, it's just it's surviving that pretty well. Capacitance range, no, nothing at all. So, and we switch it back. Uh-oh, 233, what's going on? It's slowly creeping back up to 242, but I don't know. Let me check it out. No drama at all. It just took I guess it needed a couple of seconds to recover, that's all. I'm putting it on cap range. There's 100 nanofarad cap and it's perfect, so no problem at all. It survived the overrange test. One thing with the capacitance range, check out how quick it is, right? Watch, I'll connect this cap and bingo, it auto ranges and boom, almost instantly switches to 100N. I love it. Let's look at the specs. As I said, it's 0.025% plus 5 counts basic DC volts accuracy, and that's just awesome. But that's what you expect from a top of the line, $400 odd multimeter. But it also matches that 0.025% on the resistance range as well, which is fantastic. But what's also even more impressive is the DC current spec. The Fluke 87 is like 0.2% on DC current, but the Agilent is 0.05%, plus 5 counts on the microamp ranges, and it's 0.15% on the milliamp ranges. Heck, even the diode test range is 0.05% plus 5. The Fluke has 2% on its diode range. Now, of course, on AC, it's true RMS, and it's as low as, depending on the limited bandwidth, it's as low as 0.4%, or as high as 0.4% accuracy. But that blows out to about 3.5% if you go to over its full 100 kilohertz bandwidth. And the capacitance range too is 1%, which is on par with the Fluke. So overall, this is a really super duper accurate meter for the money. I don't think you can beat it. And the range switch on it, well, it's got a decent feel to it. Not as good as the Gossen one, of course, which I got terribly excited about. And where's it made in? Made in Malaysia. Go figure. But yeah, at least it's better than China anyway. Of course, with the battery, it does take a standard alkaline one as well. But really, you wouldn't want to use an alkaline in here unless you're pretty desperate, I think, or if you just used it for 5 minutes here and there. It'll display as excellent indoors. I thought I'd come outdoors on a fairly overcast day. There is no direct sun, but let's check out the display on this thing compared to a good quality LCD on the Fluke. So let's switch it on, and look at that. I can't even read that. Trust me, that's on. It's it's beeping at me, but really you can't make that out at all. Wouldn't you know it? I told you, Murphy's Law of Multimeters. Look, rechargeable battery. I'll switch it on, and just during the review here, it'll switch itself off, because there we go, bang! Bloody rechargeable batteries, I hate them! So the verdict on the Agilent U1253A meter? Well, I give it a big thumbs up because of its superb value for money, bang per buck, in the high-end handheld multimeter market. It's, compared to a Fluke, you get more bang per buck. It's not as rugged, okay? The issues are that it's not as rugged. The OLED display does not work outside, okay? So forget about it, and you've got to recharge it. But if you can get over those things, if those things aren't an issue for you, this is the one to get, I think. So it'll be interesting to see what the new B series has over this old A series. That'll be interesting. Keep an eye out. Coming soon.